On November 5, 1971, the Europa 2 rocket lifted off from French Guiana. 2.5 minutes into flight, a guidance computer failure caused the vehicle to hang. The rocket veered off course, and as it ruptures into a cloud of fire, the multinational program reached a breaking point. This was the culmination of a decade of engineering failures and political silos. To understand why this rocket exploded, we have to look at the fractured institutional landscape that attempted to build it. Following World War II, European nations sought a path to independent space access. They intended to launch their own satellites without relying on the technology or political whims of the United States or the Soviet Union. This ambition was split between two agencies. The European Launcher Development Organization, or ELDO, focused on building rockets. Its counterpart, the European Space Research Organization, or ESRO, focused on scientific satellites. The program's foundation was the Blue Streak, a cancelled British military missile repurposed as the first stage of the Europa civilian launcher. Testing began at the Woomera Range in Australia. This remote site provided the isolation required for heavy missile development, but it also physically separated the engineers from their European manufacturing bases. This geographical gap mirrored a technical one. The early project prioritized national industrial interests over the establishment of unified engineering standards. The Europa rocket was a literal stack of national segments, rather than a single integrated machine. Britain provided the first stage, France the second, and West Germany the third. Each section was developed in isolation, often thousands of miles apart. Management was handled through indirect contracting. In this system, national governments controlled their own domestic contractors, while the central ELDO agency acted as a mere coordinator. The ELDO Secretariat lacked the legal authority to force these contractors to communicate. Technical documentation and quality standards varied from country to country, with no central power to enforce a single specification. The F-11 failure was a direct result of this disconnect. Static discharge from the fairings traveled down to the third stage, causing the British-built guidance computer to hang. Poor electrical integration between the national stages turned a minor signal into a mission-ending catastrophe. Internal reports from the time describe a vehicle with almost no design coherence. Engineers were building components for a machine they didn't fully understand. While the rocket program stalled, the satellite agency, ESRO, succeeded. It operated with a centralized structure and a clear corporate status modeled after CERN. The ESRO Director General could sign direct agreements with member states, allowing the agency to move with a speed and authority that ELDO lacked. Between 1968 and 1972, ESRO successfully launched 7 research satellites, demonstrating that centralized management could produce reliable results. However, because Europe's own rocket was failing, these successful European satellites were forced to fly on American launchers. Costs for the Europa program escalated 600% over original estimates. By the early 1970s, the political will to continue funding a fractured project was gone. The hardware failures exposed the limitations of the ELDO model. Integrating 3 separate national programs into one machine proved impossible without a single governing body. In 1971 and 1972, European ministers negotiated a series of package deals. They agreed to abandon the disjointed Europa design and replace the existing agencies with a single unified organization. They established the principle of juste retour, ensuring that member states received industrial contracts in proportion to their financial contributions. On May 30, 1975, delegates met at the Ministry of Foreign Affairs in Paris. This was the moment of transition. Plenipotentiaries from 10 states signed the ESA Convention, merging the scientific goals of ESRO and the launch ambitions of ELDO into the European Space Agency. Leadership fell to figures like Roy Gibson and Michel Dornano, who were tasked with turning a decade of fragmented work into a unified command. This unity produced immediate results. Europa was scrapped in favor of Ariane, a rocket that finally gave Europe independent access to orbit. ESRO also became a global partner for NASA, developing the Spacelab module for the Space Shuttle program. The 1975 convention provided a legal and managerial framework that has sustained European space science for 5 decades. The hardware failures of the 1960s acted as a catalyst. They provided the proof that European space access required a merger of legal and technical command. Today, the European Space Agency is a primary example of how international cooperation can succeed when national interests are subordinated to a central mission. Subscribe to Cosmora HQ for more in-depth looks at the history of exploration. In the comments, let us know which mission you think best represents European unity.